Welcome back, everyone. Houston Math Prep here to do a video for you on the product rule. When we are trying to find the derivative of an expression and it's a product of two different functions that both have the variable in it, we cannot differentiate it just one term at a time like we've been doing it with sums and differences. So what we mean by this is so far you've been doing things like x cubed plus x squared plus 5x plus 1, just maybe going one term at a time and using something like the power rule. Here, we cannot do this one term at a time. I have a function of x times another function of x, and I can't just go through and take the derivative of each term and then multiply things that I get. So for something like this, what we'll need to do is use what we call the product rule. Our product rule looks like this. It says the derivative with respect to x of some function of x times another function of x, so we're calling the first one f and calling the second one g, is equal to f prime of x times g of x plus f of x times g prime of x. This looks like a lot at first, but it's really not so bad. Okay, so you start with a function times another function, and you'll notice that what we have is we have the derivative of the first function times the second function plus the regular first function times the derivative of the second function. So when you look at this pair, you notice we took the derivative of f and left g alone. And then we add, and then in this pair here, we left f alone and took the derivative of g. So you're just taking the derivative of one of the functions at a time, leaving the other alone, and then adding. Let's do some examples. So we want to use the product rule to compute our derivative with respect to x of, we have 4x squared plus 3 times x cubed plus 5x. I've got our product rule up here. Okay, so this is going to be our f of x, and this is going to be our g of x when we compute the product rule. So that will be equal to the derivative of f. We're going to use the power rule here. We have 4x squared. The 2 comes out front and multiplies the 4 that's already there, so we get 8. The power goes down by 1, so we just have 8x for this term. The derivative of plus 3, that's just a constant, so the derivative of a constant is 0. And so we won't write plus 0, we'll just say 8x. So this is our f prime. And now g, so that just means leave g alone, don't do anything to that. So that will be x cubed plus 5x. That's our g part. And now we've done the first half, so now we add and then we do the derivative of the opposite function, right? So leaving f alone this time, that would mean we keep the entire 4x squared plus 3. That's our f. And now times g prime, the derivative of g is going to be, power rule gives us a 3 coming out front, power goes down by 1 to x squared, plus derivative of 5x, we have a 1 here, 1 comes out, we keep 5, power going down by 1 gets rid of the x there, so this is my g prime here. So we've got our product rule, and now we need to distribute and do some simplifying. So let's go ahead and do that. Distributing 8x in there, we'll get 8x to the 4 plus 8 times 5 would give us 40, and then x times x gives us x squared. Plus, let's do some distributing here. 4 times 3 is 12, x squared times x squared is x to the 4, times 5 would just give us 20 x squared. Distributing the 3, we would get 9x squared, and then 3 times the 5 giving us plus 15. Now let's go ahead and combine like terms. So I have x to the 4 is there and there. So that will be 20x to the 4. And then I have a lot of x squareds. I have 40 plus 20 plus 9 there. So that's 69x squared plus 15, all right? So we get 15. Okay, so that's our derivative using the product rule. Looking at another example, we're going to find the derivative of the quantity t squared plus 6t times the quantity 3t minus 4, obviously taking the derivative now with respect to t. So this is my f. Now it's really f of t, right, instead of f of x, but that's okay, just thinking of t as the variable. And this is g. We want to get good practice with using variables beside x, so don't change everything to x and work it and then change back. Just use what you have and get used to that. Let's go ahead and do f prime g, right? So derivative of this and then leave this alone. So derivative of f, power rule here, the 2 comes out front, t to the 1, so that's 2t, plus 6t to the 1, 1 comes out, we still have 6, power goes down by 1, so no more t's. This is our f prime, times g, so leaving g alone, 3t minus 4, that's the first half, plus Now we have just regular f, so we'll just write down t squared plus 6t. That's our f. Now times g prime, so the derivative of 3t minus 4. 3t to the 1 comes out, and we get 3, no more t. Derivative of a constant negative 4 is 0, so our g prime is just 3. And now we can distribute and do some simplifying. So 2t, we would get 6t squared minus 8t. Distributing the 6, we would get plus 18t minus 24. Plus, now what we have here, distributing the 3 this way, so we'd get 3t squared there, plus 18t. And combining like terms, I have a t square here and here, so that will give us 9t squared. I also have, let's see, negative 8t plus 18t, that would be 10t, plus another 18t would make 28t. And then our only constant is minus 24, so minus 24 there, and that is our derivative of this using the product rule. Looking at our next one, now we have functions of s multiplying together, so we have s cubed plus 2s squared plus s times the quantity s minus 4. This is a product rule, function of s times another function of s, taking the derivative with respect to s, obviously. All right, so let's do our f prime g first. This will be our f, and this will be our g. You can certainly pick them in the opposite order if you want. You'll get the same thing in the end. But so f prime here, we have a power rule. 3 comes out in the front. Power goes down by 1 to s squared plus 2s squared. Power comes out front, multiplies the 2 that's already there. Power goes down by 1, so we just get s. And then this is s to the 1 here, so 1 comes out. And the power goes down by 1, we have no more s's left. F prime is that. Now g is copied exactly as it is, so s minus 4. That is our g, so plus after that, done with the first half. Now f g prime, so write down f just as it is, s cubed plus 2s squared plus s. And then times g prime, so the derivative of s to the 1, again, would be 1 here. Derivative of negative 4 is 0, so just 1 there. All right, distributing our 1 is going to be easy from g prime, right? But we'll have a little bit of distributing to do with f prime g over here. Let's do that. So distributing, I'll actually distribute this shorter one into this. So distributing s there would give us 3s cubed plus 4s squared plus s, so I've distributed s. Now distribute negative 4, that would give us minus 12s squared minus 16s minus 4. Distributing 1 isn't really going to change any of that, right? So we'll just get plus s cubed plus 2s squared plus s. And now let's just combine like terms, right? Cube here and here gives us 4s cubed. Square terms here and here and here. So 4 minus 12 is negative 8 plus 2 is negative 6 s squared. S term here and here and here. S plus s gives us 2 s's minus the 16s, that's negative 14s. And we have minus 4 as our only constant term. So we could say that. If you really want, you could factor out the common 2, right? If you want, you could say 2 times 2s cubed minus 3s squared minus 7s minus 2, if you like. You certainly don't have to, but if you feel like that would make it nicer for you, you can do that. Let's look at one last example, and we want to show you how you can avoid the product rule by simply just distributing first and then taking the derivative. So with this one here, you have the derivative with respect to x of 5x squared, which is a function, times x to the 4 minus 3x squared plus 6x. That's another function of x. You might think of this like f times g, and because it's a product, you need to use the product rule. But if we just distribute the 5x squared first, then we won't have a product of functions anymore. So let's do that. So that's going to be then the derivative. So we're not taking the derivative, right? We're just distributing. 5x squared times x to the 4 would be 5x to the 6 minus 5x squared times 3x squared would be 15x to the 4, and then plus 5x squared times 6x would be 30x cubed, x to the third. And now if I take the derivative of this after I distributed, these are all just a power rule, term by term, no more product rule needed, right? So sometimes if you just have one term, it looks like maybe the distributing is easier up front, then do that. But I wouldn't go to great lengths to distribute and take 10-15 minutes to distribute a bunch of terms into other things just to avoid the product rule. But here it's nice, right? So 6 coming out front will give us 30, power going down by 1 will give us x to the 5. Minus 4 coming out front multiplying the 15 will give us 60. Power going down by 1 will give us x cubed. And then 3 coming out front multiplying the 30 will give us 90. Power going down by 1 will give us x squared. You could go ahead and leave that as your answer there. You might also consider, if you think it's worth it, to factor out the common factor and say, well, we can pull out a 30 and an x squared, and so left over you would have then x cubed in the first term minus 2x in the second term, and then the last term we would just have positive 3 left. So either of these I think is a good answer for this derivative. Okay, everyone, that's our product rule and maybe how to think about working around the product rule occasionally. Thanks for watching. We'll see you in the next video.